Let's take a look at the solutions to problem number 20. A lot of these are memorized. However, you can also draw pictures. For example, if you draw a very long, kind of exaggerated rectangle, pretty easy to see here that these angles are not going to be bisected. So that is a false statement. Remember, if you can come up with a counterexample, it's a false statement. Second one, if the diagonals of a quadrilateral are perpendicular, it's a kite. So notice here, it's not saying are a kite's diagonals perpendicular? It's saying if I have a shape that has perpendicular diagonals, does it have to be a kite? And the answer is no, because they don't tell us that one diagonal has to be bisected by the other. So for example, I could do something like that, and well, it's kind of a kite shape. It doesn't actually meet the definition of a kite, so that is a false statement. Consecutive sides of a rhombus are congruent. Yes, rhombuses have 4 congruent sides. Consecutive sides are next to each other, so that is a true statement. If the diagonals of a quadrilateral bisect each other, it's a parallelogram. That's one of our 5 rules for proving a parallelogram. Notice they don't say the diagonals have to be congruent. It doesn't say they have to be perpendicular, just that they have to bisect. And so you can actually make a shape, and you can look at what you can prove. And I know the one that I drew here just kind of looks like a rhombus, but it's not necessarily. The big thing here is these vertical angles are going to have to be congruent. So these 2 triangles are congruent. That's going to make these opposite sides congruent. And then meanwhile, these 2 vertical angles are congruent, which is going to make these triangles next to each other congruent. And that's going to make this side congruent to that side. And you'd have both pairs of opposite sides congruent. So yes, the shape will have to be a parallelogram. And you can also use alternate interior angles and show the sides are parallel. Every square is a rhombus. Well, a rhombus is a quadrilateral with 4 congruent sides. The question is, does every square have 4 congruent sides? Yep, true statement. Every rhombus is a square. So on these is-a questions, think about the base requirement for the shape. Square has 4 congruent sides. It has 4 right angles. Does every rhombus have 4 congruent sides? Yes. Does every rhombus have 4 right angles? Nope. Some rhombuses are squares, but not all rhombuses are squares. Every rectangle is a parallelogram. Well, parallelograms have opposite sides parallel. Are opposite sides of rectangles parallel? Yep, which means every rectangle is a parallelogram. Diagonals of a parallelogram are congruent. That is a false statement. If a shape's leaning, you're going to have basically a short diagonal going one direction, and you're going to have a long one going the other direction. First of all, it can be a little bit hard to show, but hopefully you can kind of see there that that basically we've got 2 shorter pieces going this way, we've got 2 longer pieces going that way, so that's not a true statement. Some parallelograms have congruent diagonals, but just rectangles and squares. Okay, the slope of the altitude of a triangle is the opposite reciprocal of the slope of its corresponding base. Yes, altitudes hit at a perpendicular, and perpendicular slopes have opposite reciprocal slopes. All right, filling in angle measures here, we have a rhombus. HOB is 10 degrees. We can fill that in. Remember, rhombuses have perpendicular diagonals, so you've got right angles all the way around here. That's really important. So if I subtract 90 and 10 from 180, that's going to leave me with 80 for this angle measure. Rhombuses actually break up into 4 congruent right triangles. The angles are bisected, so you're going to have an 80 over here, you're going to have a 10 over here, you're going to have a 10 here, you have an 80 here, an 80 here, and a 10 there as well. So those can't be filled in pretty quickly. Parallelograms take some more work. PRA, that angle there is going to be 40 degrees. And PLT, that angle is going to be 15 degrees. And PAL is 30 degrees. And you can use parallel lines, alternate interior angles, you can use congruent triangles. For example, if you look at these alternate interior angles, that 15 there will match up with the 15 down here. This 40 will match up with the 40 up here. This 30 will match up with the 30 over here. You've got all kinds of things. 40 plus 15 is 55. You now have a triangle. You can do 180 minus 55, and that's going to be 125, right? So that's going to be a 125 degree angle there. Vertical angles are congruent. That's going to be a 125. You got a straight angle here. So 25 plus 55 is going to give you that angle there, and then that other vertical angle would be 55. Now you've got 2 out of 3 angles in a triangle. So you've got a 55 and a 30, which adds up to 85. And if you subtract that from 180, that's going to leave you with 95 for this angle, which because of alternate interior angles is going to give you a 95 over there, right? And finally, the rectangle, RCE is a 23-degree angle. Of course, alternate interior angles, this is also going to be 23 degrees. They break up into isosceles triangles, so actually that's going to be a 23, that's going to be a 23. And of course the angles are right angles, so you can take 23 away from 90, and you're going to get 67 degrees for each of these other angles here. And then you could take the two 67s here away from 180. 67 plus 67, I believe, is 134. So 180 minus 134 is going to end up being 46 degrees, it looks like. Is that right? I think that's right. So that's going to be 46, and that's going to be 46. And you have a straight angle here. These have to add up to 180, so 180 minus 46 would end up being 134. 134. And you can also check down here, like, do these angles all add up to 180? 23 and 23 adds up to 46. 46 and 134 adds up to 180. So you should be able to check. Okay, the rules proving parallelograms. Need to know the 5 ways of proving parallelograms. Both pairs of opposite sides parallel. Both pairs of opposite sides congruent. Diagonals bisect each other. Both pairs of opposite angles congruent, or one pair of opposite sides both parallel and congruent. This one, the diagonals bisect each other. B, one pair of opposite sides is parallel and congruent. This one here, both pairs of opposite sides are congruent. Be careful on D. One pair of opposite sides is parallel. One pair of opposite sides is congruent. There is a shape that is not a parallelogram that has one pair of opposite sides parallel and one pair of opposite sides congruent, and that's an isosceles trapezoid. I am not saying that this proves this is an isosceles trapezoid. I'm saying this is not enough information to know for sure that that's a parallelogram, because they're two different shapes that have those features, okay? This one here, you got a pair of alternate interior angles that are congruent, which is going to force those lines to be parallel, and then both pairs of opposite sides are parallel here.